Hello everyone. Today I am going to discuss the fourth problem of AtCoder beginner contest 348, which is medicines on grid. So what is the problem? We are given a grid with H rows and W columns. So we are given a grid with H rows and W columns where each cell of the grid contains one of the following. It could be empty cell. It is represented by a dot. If it is an obstacle, it is represented by a hash. If it is at the start point, it is marked as S. Otherwise, if it is a target, it is marked as T. So in the grid, there will be one starting point and one target. Now we can either move horizontally or vertically, and we have to find if there exists a path from source to target. So uh, this much of the problem is quite straightforward, and this could be solved using simple BFS. But here some other points are also mentioned that is important. There are some pairs in pairs Ri comma Ci. That means if you are at that particular cell, you can eat that medicine, you can take the medicine and set your energy level to EI. And when you are moving from one cell to another cell, at any adjacent cell you are moving, then your energy will decrease by 1. Now these are the additional constants along with the like obstacles. So what are the constants? So we have a grid. Let me draw the grid first. So let's draw a 3 cross 3 grid. Now there will be, let's say this is a starting cell and this is the target cell, and these are empty cell, and let's say there are two obstacles here. One is here and another one is here. Now if there is no concept of health or taking medicine, then what we can do, we can do some kind of BFS, and we'll go to this path and we'll reach to our target cell. Now what is the concept of medicine? So there will be in type of medicine. So initially the health of the player is 0. Initially the health of the player is 0, and there will be in medicines. So this cell, let's say, has a medicine with value 2. This cell has a medicine value 3, and this cell has a medicine value of 2. So let's take that only. Now when we are at the first cell, we will take the medicine with value 3. Okay, now our health is 3. Now we'll move to the this cell. Now our value will be 2. Okay, now we'll move to the third cell. Our value will be now 1. Okay, now from 1 we can move to the this cell. Our value will be 0. Now we can take the medicine here, and our health value will be 2. Now we can move to the target cell with health value 1. Okay, so this is possible. But let's say instead of 3, the health value here is 2. Then after taking this path, the health value is 1, and after taking this path, our health value is 0. So now we can't move to the adjacent cell because our health is 0. So that's why if this value is 2, then our answer will be -1 simply. Okay, so I hope you get the problem statement. Now let's take one example. I think I have explained one example to you, so I think explaining another example will be a waste of time. So let's jump into directly observations. Okay, so let's jump into observations. Okay, so for our first observation comes from so let's discuss about the brute force algorithm. Okay, the brute force algorithm will be to traverse all the paths. Okay, traversing each and every path. So you can take some kind of recursion state where we are at some index I, and index I means the row I, and column J with some value, some health value H. Okay, so from this recursion state we can move to another recursion state to some, let's say, neighboring I, call it Ni comma Nj, and this could be either H minus 1, or you can take the maximum of H minus 1, maximum of H minus 1, and the A of Nij, or you can say A of Nij means the health of Nij, you can say H of Nij. So this is the transition state, that we are moving I comma j comma h to Ni comma Nj comma this state. So here you can think about some memorization stuff using DP, that we can directly store I comma j comma h in a map and use the memorization to solve this problem. This is not possible because of the constants. The constants on H and W are 200, so it is order of 200 square if we take order of n into m. And if we take age also into consideration, then the value of age could be or ei could be hw. The value of ei could be hw, which is nothing but nm. So that overall time complexity will be n square m square, which is 8 into 10 to the power 8, which is definitely not possible. So taking this memorization state will not help us. So now what could be our second solution, second possible observation, or second approach you can say. So we have discussed the first approach where we are storing I comma j comma h in a map and trying to do traverse every neighboring cell and modifying the value of health, which is not possible because of the constants. Now our second approach will be one greedy one, or you can say some graph algorithm will use. So what is that? So let's say we are at some index. Let's say when I am telling this is index, you think about I comma j, right? I comma j as a pair. So when we are at some cell I comma j, we will try to, if if I comma j comma h is possible, then if we are at some cell I comma j and with health h we can reach to target from this is possible, then for every value I comma j comma capital H, where capital H greater than H is also possible. Okay, if I comma j comma H is possible, then I comma j comma capital H is possible. This is our first critical observation. Now what is the second observation we can make? The second observation we can make is that we can store these values in a set, and we will take the cell which we can go to, and we will take the cell with maximum health. We will take the cell with maximum health. So what algorithm you can think when I am talking about this approach, like getting a cell with maximum distance? So we can think about Dijatra's algorithm, where we try to find shortest possible path. So here, instead of finding shortest possible path, what we are doing, we are taking it as the maximum health. So the algorithm is kind of similar. So instead of taking the minimum value, we are taking the maximum value. Okay. So for we'll initially we'll let's call it as source I. So initially we'll put source I and source I comma source j, and health of source. Okay, so let's call that h. We'll add this in our set, in our Dijata set which we are using. And after that, so let's jump into the code. I think you will understand it better. So let's expand this. So what I am doing, I am taking this a will contain my health value. So a of ij is nothing but what is the health of the current cell, what is the maximum health of the current cell. Okay, so I am here I am taking the inputs. Here this part is for taking inputs. Now set, I am taking one set. So set value will contain what? So set is a tuple of three integers. First one is minus of health, and second one is index I and j. Okay, so why we are taking minus of h? We can use h also, but we have to take the last element of the set then. But when we are taking minus of h, we can take the first element of the set, and we will get the cell with maximum health. Okay. Okay, I hope you get it, what I am trying to say. So initially this part is to find which cell is the source and which cell is the target. So if Sij is source, we are marking this as source as I comma j, and if it is T, then we are marking destination as I comma j. Now I have already told that initially in the set we will insert health of the source, health of the source, and source row of the source and column of the source. That's what we are doing. We are putting health of the source in negative, and row of the source and column of the source. Okay. Now this part is our typical Dijatra algorithm. In Dijatra algorithm, so this algorithm. So we'll use Dijatra algorithm here, but we have to have some modifications to the Dijatra algorithm. So I suggest you to stop the video here and look at what Dijatra algorithm with a set does, and then come back again to the video. You will understand my code and approach better. Okay. So let's jump into the code again. So here what I am doing, I am taking the first value of the set. The first value of the set will be the cell with maximum health. Okay, and we are erasing the cell from the set. Now here I am just decoupling it. I, J, and E is nothing but our health, you can say. Now, if I is the destination, I comma j is a destination cell, we will marking the flag as 1 and breaking. If flag is 0, then our answer will be no. If flag is 1, our answer will be yes. Now, if E is 0, that means our current health is 0, then we can't move further. So that's why we are going continue. Okay, we are doing continue. We will move on to the next element of the set. Now, here this part is for iterating over all the possible neighbors. I have explained this earlier also, that when we have to iterate over all the neighbors in a matrix, we will do dx could be from -1, 0, and 1, and dy could be from -1, 0, and 1. We will take all this combination. There will be 9 combinations, and among them one is invalid, which is 0, 0, because that will lead to our current state. We'll move to x plus dx and y plus dy, and uh, one is invalid state here. And also you have to consider when we can move diagonally and when we can't move diagonally. When we can't move diagonally, our condition will be that absolute value of dx plus absolute value of dy is 1. Then only we can move to the x plus dx and y plus dy cell. And if diagonal is allowed, then this condition is not needed. Okay, so that's why we are checking that absolute value of di plus dj is 1, and the cell I plus di and j plus dj is valid, and the cell I plus di and j plus dj is not containing an obstacle, then we can move to the cell. Now here one important condition lies, that if the current cell is already visited and the health of the cell, I have already mentioned now, if I comma j comma h is possible, then I comma j comma h, which h, capital H greater than small h, is also possible. So uh, if we have already traversed the current cell we are at, sorry, the neighboring cell, and the health of the neighboring cell is greater than the health we will be moving to, then we will not add this contribution here. Okay, now here we are checking that if the value of the current cell is in the set, we will remove it from the set. Again we are doing a of I, the health of the current cell will be e minus 1 comma health of the neighboring cell. I hope you get it. Now we are inserting that again back into the set. This part is quite similar to the Dijkstra algorithm, and we are marking the cell as visited. This visited is not needed for Dijkstra algorithm, but here it is needed because of this, because we can again come back to the current cell and we don't want to add that cell to the set again. So at the end, if flag is 0, we are marking it as no, otherwise we are printing yes. I hope you get the solution. So let's go back and explain the approaches again, a short recap. So why our first approach is failing, where we are storing I comma j comma h in the set because it does not fit in the constants. And our second approach, the first observation of the second approach is that if I comma j comma h is possible, then all the values capital H which is greater than H is also possible. This will help us. Again for this we are using Dijkstra algorithm, and we will go to the cell with maximum health, and we will try to go to the neighboring cell of that current cell, and by that, using Dijkstra algorithm, we have solved the problem. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will provide the link of the code in the description box. If you find this video helpful, please like the video and subscribe to my channel. Thank you.